Okay, so welcome back. This is part 4 in our series where we're helping you to understand what you see here, which is a laptop motherboard, how it works, and ultimately we're going to help you understand enough about this so you can actually go through and repair or work on these motherboards and really understand what's going on the motherboard rather than what you see often on YouTube is people just say, hey, measure this, and you're an expert. Well, actually, you need to understand what's going on these motherboards, and we're going to help you do that in this series. Now, in the part 1 of this series, we showed you a very simple explanation of the input DC coming from the wall adapter 19 volts and how the switching works to turn this on and off and how you sense voltage and current. In part 2, we showed you this circuit here, which is a very, very simple circuit that's repeated many times on your motherboard. You really need to understand this particular circuit because what it does is it takes the 19 volts from the wall adapter or 11 or 12 volts from your battery and converts it down to the voltages used by the components, such as 3.3 volts or 5 volts or any other voltage, DC voltage used by your components. And then in part 3, we took that circuit and we did a computer simulation so that you can actually go in and measure values, you can look at traces of signals, and you can, for free, run this piece of software called LT Spice. You can do a simulation of that particular circuit and really understand. You can measure currents, you can look at voltages, you can look at powers, you can change values and say, hey, what happens if this changes? You can actually simulate that on your computer. Again, it's a very simple piece of software. I did a 13-part series on how to use this LT Spice from beginner to expert. And again, it's free software and it's a great way to learn electronics. And as you can see here, we've got that circuit where we've got our 19 volts, we've got a couple MOSFETs, we've got a controller, we've got an inductor and some capacitors and then an output. And here we are measuring the voltage coming out of these switching MOSFETs into the inductor. And that's this blue PWM signal. And then the current through the inductor, as we said before, the inductor serves to slow down the rise of the current through that inductor. And that's in red here. And then that gets fed into this capacitor and gives you a flat DC. Now, in this video, what we're going to do is we're going to talk about some of the steps that I recommend that you go through in order to really learn about motherboards. Again, watching a video on YouTube isn't going to help you. You have to actually, at some point, if you want to learn, you're going to have to sit down, get the components, figure them out, and do the hard work of understanding what's going on. So, the first step I recommend is you go get a cheap motherboard like you see here. And it's called a replacement motherboard or a repair part. In fact, this is one I got on the Walmart website, and it was only $14 for this really nice motherboard. Had a CPU, it had 8 gigs of RAM already. So $14, and it's really, really important that you take this step and go find a motherboard that you can start looking at and reverse engineering and understanding what's going on. So now, why do you need a motherboard? Why is that important? Well, there's a bunch of reasons why you want to go get an inexpensive motherboard as the first step. One is for learning. Another one is because you're going to have all of these components, these USB ports, all of these capacitors and MOSFETs and so on, and you can use those in the future as spare parts. So one benefit of getting a cheap motherboard is at least it gives you spare parts for the future. And as I mentioned, you can go through and hook this up and apply power and measure actual values. So it's a great way to learn about what the expected values are on the MOSFETs and on the different voltage rails. You can go through and measure those. You can use your oscilloscope if you have one. You can use your multimeter. You can also measure temperatures. A lot of people don't seem to realize that your multimeter probably has a thermal sensor that you can go in and just touch the different components and see what the temperatures are. Also, it's an opportunity to practice soldering. A lot of these components are very, very tiny, so it's really good to get some experience with soldering. And also, it gives you a view into, before you start working on dead motherboards, you can fire this up and you can see what good values are for the motherboard. So it'll give you a little background. When you have a dead motherboard, it'll give you an idea of what to expect for good values. And also, as I said, it's really nice if you're going to do a computer simulation like this, you can compare the results of the simulation to what you actually measure when you fire up this board and get it running. You know, look at the MOSFET values and see, does it match the simulation? If not, that's another learning experience. So really, really important that you get a very inexpensive motherboard and start working on it and doing some reverse engineering and measurements and simulations. Now again, this is one I got from Walmart. Surprisingly, only $14. It was pretty much all set to go. But you can, just Google something like motherboard replacement and go into the shopping section on Google and sort by price. You can find a lot of inexpensive motherboards that you can just buy and start working with. You could also, of course, go on eBay or any other website. Here in the US, you can go to Goodwill, see if they have any computers. You can look online for fully working laptops that you can buy for very inexpensive. They'll probably be very old, but at least they can give you an idea of what are the components of the working laptop. Now, one of the things I recommend is, like this one I bought from Walmart, you find one that's got a working CPU, RAM, and as many other components included so that you can, without a lot of work, apply 19 volts. Maybe it even has a hard drive and you can have Windows on it and you can fire it up. So try to find one that's got a lot of extras on it. And also, you probably want to find a brand where you can find for example, a service manual for the computer, because it will help you to understand what's going on with the computer and what all the ports are and the components. So I like to use HP because they have some really good service manuals with their computer. So here I've got a repair part, and it's got the HP product number for the repair part, laptop motherboard for HP Pavilion X360. Now, like I say, once you get that motherboard and you know which computer it goes with, you can, in this case, go to HP, and it's got the HP Pavilion X360 service guide, which has a lot of really, really good information about the different components, what the processor's options are, the graphics, memory, what the memory is. In our case, it came with 8 gigabytes, what the storage is. And then if you want to go and buy some additional parts, for example, if you need a power switch or you need an SSD or you need an I/O board, you can go right into this service manual and it will tell you what the part numbers are to replace those and add them to your computer. It's got the I/O ports, what to expect, and it also tells you how to install and uninstall the different components. Really great way to learn about your motherboard. That's why I recommend you use you get a motherboard from a big manufacturer who's got a lot of information. Now, once you have your motherboard, the first thing I like to do is I like to take some photos with my smartphone of the motherboard itself. And the reason I do this is because then I can move the image to my computer and I can look at the different part numbers of the components. And you can see here, I can also look at the traces. I can see how many pins on each part number. I can see the markings on the top of the integrated circuits. And from that, I can start to figure out what these components are. But it's really nice to have multiple images of your motherboard and the different components. Now, again, it's very important when you take the images, when you take the photos, that you have the right lighting. If you have a light coming directly down on these integrated circuits, you're probably not going to see these markings on the integrated circuits. So I recommend you place a flashlight or something that's shining across the tops of the integrated circuits, and that way you can see the markings. So again, take photos of different parts of the motherboard and make sure you can see the markings, and hopefully you can see the traces, and that will help you for the next step. And the next step is trying to figure out for each component or each major component what it is, what's the manufacturer, and ultimately find a data sheet. Because if you want to understand what's going on, it's really, really important that you find a data sheet for each component, or at least a similar component, so that you know what's going on. You know what the pinouts are, you know how to take measurements, and you know what the circuits do. Now, one of the challenges, once you've got this data, it can be a real challenge to find out what each component is solely from the product markings on the top. These do not necessarily tell you anything directly about the component. In this case, you've got a logo for the Alpha and Omega company, but for a lot of integrated circuits, you're not going to have a direct model name on the integrated circuit. So you're going to have to do some detective work to figure out for the product markings on the integrated circuit, what's the actual model number? And that can take quite a bit of effort. But the effort is what helps you to learn. Going through that effort of figuring this stuff out is what is really beneficial and helps you to learn. Once you've got that, what I like to do is I like to keep a list of all of the data about that motherboard. What's the model number, the date, any markings on the motherboard, some links to the support for that particular computer, the model that the motherboard goes with, the drivers. And then I take like the CPU, the RAM, the BIOS. I look at the markings. I see what from the manufacturer's service guide, what the battery model is, and all of the data associated with that. Also the external connectors. And up here I've got from the service manual, I have got the part number for each of the add-on components like a battery, the fan, the heat sink. That's really important if you want to order those on eBay to add those to your motherboard. Then I've got a list of external connectors. That can be really important because it can give you some information about the age. For example, if it's all USB 2, you know it's kind of older. If it's got an SD card reader like this one. So all of the external connectors, I've got a list of onboard connectors, keyboard, touchpad, speaker, LCD, DC-in, and so on. And then I go through and I keep a list of each of the components. And here is the manufacturer, and in blue I've got the marking on it, the Super I/O battery charge controller. And a lot of this stuff takes a lot of effort to figure out. So this is going to take some effort, but again, it's a great way to learn, you know, what the components are, what the MOSFETs are, what's the manufacturer, what's the marking, how do you find the data sheet. And I keep track of all the data sheets, transient voltage suppressor diodes, some of their properties, and so on. So really, this is a great way, once you've got your motherboard, keep track of all the components and go through the exercise of trying to figure out what they are and what they do. And here's another example of another section on the motherboard we briefly showed before, where we've got these inductors here that are presumably part of the DC to DC converters for different voltage levels. And you can see here we've got these 20-pin integrated circuits that are probably the DC to DC controllers for the MOSFETs that are generating the 3 volts and the 5 volts and so on. So you can see I've got a 20-pin NCP 81201. Turns out it's a on-semi DC controller. And then I've got one that says 24 equals 3E. After a bit of research and reverse engineering, we figure out this is a Rich Tech DC controller, I believe. And then we've got others here. And so it's going to take some effort to figure out, because these markings do not necessarily tell you the model or the number of the product. They are like a code. Sometimes they have a date in here. You have to go to their data sheet and convert this marking to an actual product code. So it can take a lot of effort, but the good thing is that effort and that reverse engineering is a great way to learn about things and find out where you can get data and so on. So I really encourage you to go through the steps and go through as much of this as you can, trying to reverse engineer it. So now let's take an example of how we might figure out a particular integrated circuit. What's the model number, what's the manufacturer, and what does it actually do? So here's a part of our motherboard where we've got an inductor, we've got a couple MOSFETs, we've got some capacitors, and as you can imagine, we've got this device here which is probably controlling the switching of the MOSFETs to convert from 19 volts down to some lower voltage. And if you look at the markings on the package, it says 24 equals 3E S2X. Now, how are we going to figure out what's the manufacturer, what's the model number, what's the product, and what's the data sheet? Well, one really good resource for something like this is what's called badcaps.net. And it's basically people who repair computers and laptops and so on have a forum where they share information about the different components and motherboards and so on. And in the badcaps.net forum, we're in the troubleshooting hardware and devices and electronics theory, in the troubleshooting laptops, tablets, and mobile devices, a sticky post called IC marking codes and data sheets. And this is just one really helpful resource for taking, in our case, this marking which says 24 equals 3E S2X and trying to figure out what is that and who's the manufacturer and how do I get a data sheet. So if you look here and you scroll down, it's got a list. You can go by manufacturer if you already know what the manufacturer is. The first one says Rich Tech, and it shows an example photo, and you can see here it says 4B equals 1G. So immediately you can, as you scroll through this, you can say, hey, wait a minute, I've got one that's very close to that. It says 24 equals 3E, so maybe this is a Rich Tech device. So then what you can do is you can go to Rich Tech and search for the device you've got, in our case a 24 equals 3E, and it turns out that 24 equals defines a particular product. And then we've got date codes and so on. So after doing some research, I found out it's a Rich Tech. The product code is 24 equals, and it's a 20-pin DC controller, and we've got a data sheet for something similar. One of the challenges is even once you've got this and you can go to Rich Tech, it may not have this device for a bunch of reasons. It may be obsolete. In this case, this is a 2016 motherboard. This may be totally obsolete. Also, some of these components are manufactured solely for a particular computer manufacturer, like in this case HP. So this might be an HP only device. It's not publicly available. It's proprietary. You can't get a data sheet. However, you can get some information about it. You know that it's 1, 2, 3, 4, 5 times 4. It's a 20-pin package. It's Rich Tech. And by doing some research, you probably know it's a DC to DC controller. It's controlling these MOSFETs to give you a DC. So in that way, you can do some research and figure out that it's a DC to DC controller. And maybe you can find a similar model on Rich Tech, or you can go to some of the electronic suppliers like Mouser or DigiKey and search for 20-pin DC to DC controllers. Now, the number of pins is really important because it also gives you more information about what this might be, right? If it's a processor, a CPU, it's going to have a lot of pins. If it's a MOSFET, it's probably going to have 8 pins. If it's a capacitor, it's probably going to have 2 pins. Here we've got 20 pins, so that kind of narrows it down to being probably a DC to DC controller. Again, you can do some research and search by 20-pin packages to see what comes up with DC to DC controllers, and maybe you can come up with something that's very close. Again, it takes some research, it takes some legwork, and honestly, that's the part that it helps you to learn. If you go through the difficult process of trying to reverse engineer this, that's what helps you to learn. And you can go to these others. We've got like an NCP 81201, and the fact that we've got a nice photo of this makes it a lot easier. We can go through and get the component names. This one didn't come out very well. We would have to redo it. But also you can see the traces coming out of this inductor going to this. You know that this is controlling this inductor. And you can see other traces going to different components. And from that you can logic out what's going on. Also keep in mind the thickness of the traces gives you an indication of how much current is flowing. Like if it's 2 millimeters or something like that, it's going to have some significant current flowing in the trace. So all of those little bits of information are really important for you to figure out what's actually going on. So here's another example of a photo of another section of the motherboard. And you can see I had to shine a flashlight horizontally across the top of this in order to bring out the markings on the top of this chip. You can see it's a 5 pins on each side, which means it's a 20-pin chip. And the marking is BQ737TI841C7LK. And again, we need to do a little bit of research and reverse engineering to find out exactly what this is. Now, if you've done any work with motherboards before, you probably recognize the BQ is fairly common marking for a chip that's used to control the incoming DC, like our 19 volts from the power adapter, and also control the charging of the battery. So this BQ chip is kind of common. That TI means it's Texas Instruments. However, this data sheet for the BQ737 is pretty much unavailable as far as I can determine. Also, Texas Instruments puts BQ737, but actually the chip product number is BQ24737, right? So you have to know that there's actually, if you want to search for it, you got to search for a 24737. Now, if you're lucky, you'll get a data sheet for this, and it's got a lot of information. In my case, the 24737 just isn't available as far as I can determine from Texas Instruments. However, there is, I think, a similar data sheet for a BQ24735, which is a 1 to 4 cell lithium-ion battery SM bus charge controller for supporting turbo boost mode with N-channel power MOSFET selector. So if you're lucky enough to get a data sheet for this device or something similar, you've struck gold, because that helps you with a lot of information. This says it's for portable notebook computers, UMPC Ultra 3 notebooks and netbooks, which is what this motherboard is from. And one of the great things about this is they often have a simplified application diagram for using this charge controller chip. And as we showed before in the first video, you take the adapter, the 19 volts, you've got the two MOSFETs, which have a gate controlled by this BQ24735. We have a RAC, which is a current sense resistor, which is measuring the current. We have the voltage divider from the 19 volts coming into this for adapter detection. And also, this controller has one DC to DC controller using the MOSFETs that we talked about with an inductor, and that is used to charge the battery. So in this one diagram, it kind of brings together what we talked about before, the DC in, the switching MOSFETs to charge the battery, and also there's communication with the host, which is the Super I/O over this SM bus to control this. So right here, you've got a lot of really good information about this and what this BQ737 probably does. Now, keep in mind, just because we found something similar doesn't mean that the one we have follows exactly this. And in fact, I think the 737 we have doesn't control the gates of these MOSFETs. I think they are actually controlled by this Super I/O. But just keep in mind that there are variations upon variations upon variations. But this does help you get an idea about what the typical configuration might be that you can look for on your motherboard. Now also, there's a lot of good information about packaging and ratings and what all the different functions are. And also it has a cycle-by-cycle synchronous to non-synchronous measurement of some of the pins as the MOSFETs switch. And for example, you can see here we've got a positive going DC down to 0, and then we've got this ringing, and then we got this PWM. So this gives us an indication. If we measure this pin on this controller, we might expect to see a PWM signal, but also some ringing. So this is a really nice bit of information if we're going to go through, as we will in the upcoming videos, connect some of these pins to our oscilloscope. We've also got some inductor current, as we showed before. We've got the rise and fall of the inductor current. So this will be a great way to compare with our LT Spice simulation, and also to compare with our actual measurements from our oscilloscope. So there's tons of good information in this if you know what to look for. It's got a detailed explanation of what's going on, what's inside of it, and all of the pins. It talks about some of the protective measures we talked about before that are built into this. It also tells you how to size some of the connected components that tell the controller what you want for different parameters. So again, if you can get the data sheets for these devices, you've struck gold, and they can be really, really useful. And if we look at the simple circuit that's being controlled by this BQ chip, we've got the two MOSFETs, inductor and capacitor. What it's telling us is if we measure right here this voltage coming out of the MOSFETs, the switching PWM signal, we show it as a very clean PWM signal. But in fact, what they say, it's going to look a little bit more like this. You got the PWM, but you got some ringing. And what I did is I did some actual measurements of the actual BQ chip pin that corresponds to this. And I came up with a scope trace that shows quite a bit more ringing, but it's a lot shorter pulse width. So in that way, you can do some actual measurements, look at what the data sheet says you should be getting, look at what you actually get, and then start to understand why we get the ringing and that kind of thing. So really great way to, on multiple fronts, figure out what's going on and understand what's going on. And you can see here we've got the low driver, which is the gate for the bottom MOSFET, the high driver, which is the gate for the top MOSFET. We've got the inductor current, as we showed before, and so on. So you can compare with a lot of different sources of information to figure out what's going on. So in the next video, we're going to proceed with doing some actual measurements and compare them with our data sheets and see if we can figure out better what's going on. So if you're liking these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.